In this video, I'll solve 5 questions of linear algebra from old question papers of CSIR Net Mathematics examination. Let me take the first question. Let A equal to 0, 1, minus 1, 1. This is the 2 by 2 matrix. Then smallest positive integer n such that a power n equal to I is. So we have to verify with the options. Find out a square. As it is a 2 by 2 matrix, you can easily get what is a square, a into a. So when you multiply this, you will get minus 1, 1, minus 1, 0. It is not equal to the identity matrix. Find out a cube similarly. That is also not equal to identity matrix. A power 4, that is a cube into a. That is not equal to the identity matrix. So 2, 4, these options are not possible. The last option remaining is 6. That must be the answer, because 1 not possible. A itself is the given matrix. That is not an identity matrix. So no need to check whether a power a is 6 equal to identity by doing all these calculations. The only remaining option is the fourth option, that is 6 answer. So hence it should be the answer. Take up the second question, that a equal to 1, 1, 2, 1 minus 2, 5, 2, 5 minus 3. Then the eigenvalues of a are. Now you observe each row of and each column of the given matrix. If each row sum is alpha, some constant, then alpha is an eigenvalue of A. Or each column sum is alpha, then alpha is an eigenvalue of A. Anything is fine. Now take up the first row, add up all the elements of the first row. 2 plus 1 plus 1. That is equal to 4. The second row also, 5 plus 1 minus 2, that is also 4. 2 plus 5, 7 minus 2, that is also 4. So each row is giving you the sum 4. Hence 4 is one of the eigenvalue. Now these three options contain 4. Now which option is the correct answer? To verify that, we can go with this formula, that is trace of A equal to the sum of eigenvalues of the given matrix. So one of the eigenvalues is 4, other two eigenvalues we don't know, is equal to trace of A. That is lambda 1 plus lambda 2 equal to minus 4 you will get. Similarly, determinant of A equal to the product of eigenvalues. That is 4 into lambda 1 into lambda 2. That gives you determinant of A comes out to be. You can check what is the determinant of this matrix. That is 12. Trace of this matrix is equal to minus 3 minus 2 minus 5 plus 1 minus 4 it is. So from this you will get lambda 1 plus lambda 2 is equal to minus 8. Lambda 1 into lambda 2 equal to plus 3. So there is one option. You can go with this formula, a minus b whole square equal to a plus b whole square minus 4 into ab. And the substitution, that part also you can do. To avoid all this calculation, what you can do is a trace of A equal to 4 plus lambda 1 plus lambda 2, which is equal to minus 4. You can verify with the option. Which option gives you the answer minus 4? That is the third option. So you can add 4 plus 4 minus 4 plus root 13 and plus minus 4 minus root 13, because these are the rational roots, they occur in conjugate pairs. So therefore you will get here equal to minus 4. You can verify directly from this, hence you will get the answer as the third option, or else you go with its lengthy calculation requires time. Instead of that, you can verify with the options. Third option is the answer. Next, third question. If A is a 2 by 2 matrix over R with the determinant of A plus I equal to 1 plus determinant of A, then we can conclude that. So, A is a 2 by 2 matrix over the field of reals. Take A as A, B, C, D. We don't know what are the values. Now, you find out determinant of A plus I. I is the identity matrix 1, 0, 0, 1. So, when it gets added to A, it becomes A plus 1, B, C, D plus 1. So, take its determinant, A plus 1 into D plus 1 minus BC. So given that A determinant of A plus I equal to 1 plus determinant of A. So make the substitutions. A plus 1 into D plus 1, that is AD plus A plus D plus 1, and minus BC, which is equal to 1 plus determinant of A is AD minus BC. All these terms get cancelled. A plus D remains equal to 0. A plus D is nothing but trace of this matrix. So trace of A equal to 0. Third option is the answer. Similarly, the fourth question, let A equal to 102, 1 minus 20, 00 minus 3, and I with the identity matrix. If 6A inverse is equal to AA square plus BA plus CI for ABC belongs to R, what are the values of these coefficients ABC? So we know that for any 3 by 3 matrix, it satisfies the equation that is lambda cube minus its characteristic polynomial is given by lambda cube minus trace of A into lambda square plus the sum of its cofactors into lambda minus determinant of A equal to 0. This equation is the characteristic equation of that given 3 by 3 matrix. So every characteristic equation satisfies its every matrix satisfies its own characteristic equation, that is Cayley's theorem. So you will get A cube plus 4A square plus A minus 6I equal to 0. This is the result. Now let us find out one by one. So what are the values of trace of A and the cofactors? Determinant of A comes out to be, you calculate that, 6. Trace of A equal to sum of diagonal elements, that is equal to minus 4. A11 cofactors, cofactor of the diagonal elements. First row, first column, 3 twos, 6. Next, second row, second column, delete second row, second column, minus 3 and 0, that is giving you minus 3. Third row, third column, minus 2. Okay, when you add up all these values, you will get the answer 1. So substitute this lambda cube plus 4 lambda square plus lambda minus 6 equal to 0. This is the characteristic equation for the 3 by 3 matrix. Now every matrix satisfies its own characteristic equation. Substitute the matrix in the place of lambda. So then we want here A inverse. Multiply by A inverse on both sides. So you will get A square. A into A inverse becomes I. 4A, because A into A inverse becomes I. A into A inverse is I, equal to 6 into I into A inverse, that is 6A inverse. So now compare the equation. What you have in the place of A, coefficient of A square is 1, B is 4 and C equal to 1. So fourth option is the answer. Last question, the trace of the matrix. The trace of the matrix, this is the given matrix. We know that eigenvalues of upper triangular matrix or any triangular matrix is equal to the diagonal elements. So now if lambda is an eigenvalue of A, lambda power n is also eigenvalue of A power n. So take the given matrix to the power 20, you leave now. Take the given matrix as A, 2, 1, 0, 0, 2, 0, 0, 0, 3, take it as A. Okay. So that's a upper triangular matrix. So its eigenvalues of A are 2, 2, 3. Now, if 2, 2, 3 are eigenvalues of A, then 2 to the power 20, 2 to the power 20, 3 to the power 20. They are the eigenvalues of A to the power 20, because this is given as A power 20. So, therefore, using this result, we know that trace of A equal to sum of eigenvalues. So, trace of A equal to, they are asking you what is the trace of the matrix. Trace of A is sum of eigenvalues. Trace of A equal to 2 to the power 20 plus 2 to the power 20 plus 3 to the power 20. 2 into 2 to the power 20 plus 3 to the power 20. So, third option is the answer. I hope you understood the solutions for all these 5 questions. Thank you for watching.